How do you make a character truly alive without a single animation? This is the challenge we've been working on for a while now. My name is Phil, I'm an indie developer and founder of Wiskered Studio. What we're developing is called FUNBRUN. Here's what it is. The genre, medieval physics fighting from a third-person perspective, 2 modes, Sandbox and Story Campaign. In the Sandbox, create any characters, customize them, and play out any scenarios. In the campaign, you start as a lone warrior and gradually become a squad commander. The name is pronounced FUNBRUN. Fun, literally fun. Brun lands in Old Norse, and built into that is the philosophy of contrast, wild, joyful freedom against a brutal, merciless medieval world. All of this sounds great, but how did we even decide this was possible? Previous projects and work with procedural systems, as well as the math behind robotics calculations, that gave us the base we needed. GDC talks on IK and more. Other games with active ragdoll and procedural animation, tabs, human fall flat. We looked at all of it and saw potential that hadn't been explored the way we had in mind. Traditional animation couldn't handle the variety of proportions, behaviors, and scenarios, especially with no animator and budget. Physical simulation was the only real option for us. There was only one thing left to do: try. Before the first iteration, we spent time on research, approaches, algorithms, how other people had solved similar problems. The concept came together faster than expected. Physics and robotics background helped a lot, and many solutions we invented ourselves. The result? A high-performance, lightweight, active ragdoll system we named PrimalCore. The first iteration was a testing ground. Fist and sword strikes, weapon switching, small characters physically climbing onto larger ones, sliding down slopes, character customization. We shared results through GIFs and short videos, collected feedback, and searched for the right feel. That's exactly when we defined the style, the philosophy, and what the gameplay experience should be. Some mechanics surprised us, behaviors that came out of the simulation that we hadn't planned for. The community picked up on things we hadn't noticed ourselves. We had a clearer picture of where we were going and real energy behind it, but the same system was running all of it, and the more we pushed it, the more it pushed back. Every new mechanic cost more time than it should have. Every experiment ran into the same kinds of limits. From the outside, it looked like steady progress. From the inside, we were increasingly aware of what the system wasn't built to handle. That's what made the decision to rebuild feel straightforward rather than painful. We weren't scrapping something that had failed, we were finished with something that had done its job. The core problem was timing. Different body sizes need different muscle timing to feel right. A giant needs slower contractions, a small fighter needs faster ones. PrimalCore V1 couldn't handle that range without killing performance. Every new mechanic hit the same wall. So we stopped adding and started rebuilding, and that became the second iteration. The current PrimalCore is the result. Optimized, scalable, carefully designed. Dozens of times more powerful and stable than before. Now let's figure out what PrimalCore is. PrimalCore is the core framework inside Unity that powers FUNBRUN. It behaves like an engine layer built on top of Unity. It includes active ragdoll, muscle simulation, AI, physics, LOD, and GPU-assisted signal distribution. All systems run as independent modules in real time. The architecture is based on a resolver. Character body, camera, and input are fully independent systems connected at runtime. Any input can control any character type. No code changes required. Modules communicate through interfaces and request data dynamically. There are no hard dependencies. Systems only run the cycles they need. Locomotion states broadcast to other systems. New modes are added by defining conditions and registering them in the framework. Contexts switch at runtime, enabling LOD that can disable not only rendering but full simulation systems. We replace Unity systems where needed and use custom GPU-assisted pipelines in parts of the stack. Every major system has debugging and visualization tools. Interesting fact, rendering the character's mesh costs more resources than the entire PrimalCore system for that same character. One of the main tasks PrimalCore handles is active ragdoll simulation. There are many different approaches to active ragdolls. We won't get too deep into the internals, but some of the ideas behind PrimalCore are unique enough that we're still deciding how openly we want to talk about them. Movement is divided into layers: base posture, torso, and head motion, then balance, breathing, body sway and landing absorption, then walking and attacks. On top of everything, micro movements and idle behavior, all layers run simultaneously in priority order. And that becomes the foundation for the most complex and important part, the gait system. Every step is split into 3 phases: lift, pause, and plant. Within each phase, every bone in the leg chain has its own time window, a normalized range from 0 to 1. These time windows automatically scale with the full step duration, double the duration for a giant, and all windows stretch proportionally while the cascade remains intact. At initialization, the system pre-builds muscle programs for every movement direction: forward, backwards, sideways, and diagonals. Each program consists of independent timed commands per joint: which joint, which axis, what angle, delay, duration, and curve. Commands for different joints and axes run in parallel. These programs are built ahead of time because the physics cycle cannot wait during an active step. The system simply picks the right program for the current direction vector and fires it instantly. Optimal foot placement considers multiple factors at once: movement direction and speed, current body tilt, angular rotation velocity, and surface geometry under the trajectory. Body sway is already a first hint at what we'll talk about next. Because the character's body doesn't just move, it constantly balances. In PrimalCore, balance is handled by multiple independent layers: pelvis, spine, and anchor bone, each responding to movement, rotation, and terrain. The spine chain distributes motion across segments, creating a smooth wave while keeping physics active. All layers operate simultaneously and independently, and the system is fully configurable to work with any creature, adapting to size, shape, and movement style. All those layers work with the body as a whole, but there's another level. Systems can influence each other. The head can anticipate turns, the torso can follow the gait cycle, and secondary motions can emerge from existing states. The same architecture drives idle behaviors and micro movements, increasing motion complexity while keeping the system modular. FUNBRUN is not built only around horizontal movement. Verticality, as climbing, heights, and jumping, is an important part of both exploration and combat systems. Holding the jump button physically bends the legs and lower spine, building jump force from minimum to maximum values. Just before takeoff, the body is additionally pressed into the surface, storing extra counterforce. When jumping from dynamic objects, they receive an amplified counter impulse, making the interaction read more expressively. To improve responsiveness, the system uses jump buffering, coyote time, and directional smoothing for jumps. Landing uses a full body damping system that regulates the character's response force to the physical world. Movement isn't everything. There are several important systems working on top of it. Some of them are locked into a specific configuration, since we're not focusing on them in the current tech demo. The breathing system models oxygen debt as a continuous gradient with frequency and amplitude parameters for each involved bone. Just by watching a character breathe, you'll be able to tell how tired they are. Each eye works independently. It has an alive, dead state, blink frequency, and speed with slight desynchronization. Mood is conveyed through the rotation angle of the eyes. The mouth works through 3 independent channels: mesh blend shapes, lower jaw position, and head rotation. All of them act simultaneously and can be fully synchronized with audio. Customization changes more than just appearance. Height, proportions, limb size, and mass directly affect the character's characteristics and abilities, as well as how they move and fight. For example, small characters will be able to nimbly climb on surfaces and other characters, while large ones will possess many times greater strength. In the tech demo, proportions are fixed to a specific configuration. The full range will become available in future tech demos. The character design is intentionally stylized. No clothing, but not naked. These are semi-cartoonish characters resembling 3D stickmen, short legs, big teeth, partially inspired by Rayman raving rabbits. We haven't decided on the hair yet. Write your ideas in Discord. We'd love to hear how you think it should look. And one more thing you rarely think about: the camera. The camera in PrimalCore is a separate core with its own modules. It doesn't know about characters, only the point it needs to track and what data to pass along. The focus follows its target through a smoothing profile based on a nonlinear distance curve. Camera collision is handled through 2 checks: distance to the target and the camera's local position, and that's what allows it to behave correctly in tight spaces or when pressed against walls. You can also set distance limits in advance for indoor areas like rooms and other enclosed spaces. FOV scales with movement speed, a slightly widening at high speed to enhance the sense of motion. There's also a separate squint mode with its own FOV, and in free camera mode, the character keeps moving while you rotate the view independently. In the tech demo, you can also switch to static cameras with keys just to observe the scene from different angles. The first public tech demo of FUNBRUN on the new PrimalCore is now available. It includes the new PrimalCore architecture, physically simulated movement, procedural gait, balance systems, camera controls, and a number of other core technologies shown throughout this devlog. Some features, such as customization, breathing, facial expressions, and behavior systems, are currently presented in fixed configurations and do not yet represent their full intended range. Access is available through Patreon, starting from the Warrior tier. Full details are available on Patreon, Discord, and the Access page. FUNBRUN is not being developed by a large studio, and there is no budget behind it. Most of what you saw today was created by a very small team, step by step, in our free time, over the course of several years. If you're curious to see what this project becomes in the next months and years, your support truly matters. Patreon allows us to dedicate more time to the project, release new tech demos, and move faster. If you want to stay closer to development, join our Discord community. That's where we share progress and talk with everyone interested in the project. For artists, composers, writers, and technical specialists, as well as anyone who simply wants to be part of this journey, the doors are open. If you are from the press, a publisher, or interested in collaboration, feel free to contact us directly. Every subscriber, every piece of feedback, and every person who shares this project with others helps us move forward. And we believe it's worth it. Because when all of this comes fully to life, something truly incredible will emerge. You'll see a swarm of small characters taking down a giant, dragging it to the ground. A giant smashing an entire group apart with a single swing of its club. An archer pinning an enemy to a wall with an arrow. Small fighters clinging to a giant's arm, while others climb onto its shoulders and shoot from above. A group forming a living tower to climb over a wall. A giant grabbing a small ally and throwing them onto an enemy ship, somewhere they could never reach on their own. A tactical sword duel, a knightly tournament, an archer runs out of arrows, a teammate tosses more into their quiver, a squad sets up a palisade, a crowd collapses off a siege ladder, hunters hide in the branches and leap into ambush, you fake your death, and enemies walk right past you. You ride at the head of your squad on horseback, hunting a bear in the forest. You hand musical instruments to your warriors, and they fall into your rhythm. Every situation has multiple solutions. Physics and character abilities give you the tools, and what you do with them is entirely up to you. This is FUNBRUN,